Thank you viewers for stopping by. I am Tutor Cletus Okoli. In today's math class, we want to look at this exponential equation where we are given if 27 to the power of x minus 3 to the power of x all divided by 9 to the power of x minus 3 to the power of x is equal to 82, that we should find what the value of x represents. Let's dive in, watch the video till the end. Alright, now from 27, I want you to see that 27 can be represented in base 3 as 3 raised to the power 3. And also this 9 can be represented in base 3 as 3 raised to the power 2. I am going to use 3 raised to the power 3 and 3 raised to the power 2 to replace 27 and the 9. And that means I shall now have 3 to the power 3 or to the power x minus 3 to the power of x, everything divided by 3 to the power of 2, which is for 9, then or to the power of x minus 3 to the power of x is equal to 82. First step. Now, by law of indices, product law of indices, x to the power of n, then to the power of n is the same as x to the power of n. And it is also equal to x to the power of mn, and can also be written as x to the power of m or to the power of n. So, that is the law of indices. That is, you can interchange the position of the powers because multiplication is commutative. That implies I will now interchange the position of these powers. I will move x into the bracket and 3 outside the bracket. I will do the same at the denominator. Doing that, I will now have 3 to the power of x or to the power of 3. Then minus 3 to the power of x divided by 3 to the power of x or to the power of 2 for the denominator minus 3 to the power of x. Everything now is equal to 82. Very good. Next I want to let my 3 to the power of x to be n. So let n equal to 3 to the power of x. That means anywhere I see 3 to the power of x, I write n. I put in n. So from the numerator, I will now have n, that is 3 to the power of x, then to the power of 3, minus here, which is 3 to the power of x, will now be n. All over, at the denominator, I still have n to the power of 2 minus 3 to the power of x will now be n, equal to 82. Now, from the left hand side, you see n is common, both at the numerator and also at the denominator. I can now factor it out to have n into n to the power of 2 minus 1. Everything divided by n into n minus 1, all equal to 82. Okay? We can now cancel out the n that is common, both at the numerator and the denominator being factored. So, what we are left with at the numerator is n squared minus 1. And by law of difference of two squares, we can expand it and write it as n minus 1 into n plus 1 because it is equal to n squared minus 1. So therefore, I can now write n, that is n squared minus 1, can now be written as n minus 1 into n plus 1. This alone represents n squared minus 1, everything all over n minus 1 equal to 82. Very good. You can now see at the denominator, I have n minus 1, and at the numerator, I also have n minus 1. I can cancel it out. That makes my work very easy. So which implies that I shall now have from the numerator n plus 1 equal to 82. This implies that n is equal to 82 minus 1 and my n is equal to 81. That is for n. But then we said here let n be equal to 3 to the power x. Therefore, if n is equal to 3 to the power x, I now replace my n as 81 equal to 3 to the power x. But 81 can be written in base 3, and that is 3 to the power of 4 is equal to 3 to the power of x. According to the law of indices, that when I have x to the power of n equal to x to the power of n, that it is the same thing as n equal to n, that once the bases are equal, that the powers automatically becomes equal. That can now be applied here to say that x now therefore is equal to 4. Answer. Thank you for watching the video to the end. But then you can take the task of substituting the value of x equal to 4 into the main equation that we are given to see if it will give us exactly what we have by the right hand side. Thank you. Please subscribe if this is your first time of stopping by. God bless you.
Na mbụ agwara m mmadụ sị